Hi students, this is Somesh. Now I would like to explain Jntuk previous question paper problems on rectangular waveguides. Okay, here the first problem. A rectangular air-filled copper waveguide with dimensions 2 centimeters and 1 centimeter is operated at 9 GHz with dominant mode. Find the cutoff frequency, guide wavelength, phase shift, phase velocity, and characteristic impedance. Okay, just observe the problem. A rectangular air-filled copper waveguide with dimensions 2 centimeters and 1 centimeter. So that means small a is equal to 2 centimeters. Small a is equal to 2 centimeters and small b is equal to 1 centimeter. Small b is equal to 1 centimeter. Okay. Next, operating frequency is equal to 9 gigahertz with dominant mode. Operating frequency f is equal to 9 gigahertz. That means 9 into 10 power 9. 10 power 9 hertz. So it is operated in dominant mode. In rectangular waveguide, dominant mode is equal to TE10 mode. Okay. So find the cutoff frequency, guide wavelength, phase shift, phase velocity, and characteristic impedance. So cutoff frequency, find the cutoff frequency, that means F suffix C. Guide wavelength, lambda Z, guide wavelength, lambda suffix G, and phase shift, beta, phase velocity, V suffix P, characteristic impedance. So phase shift is equal to beta, and we have to calculate phase velocity at the same time characteristic impedance ZT. So in given question, dimensions of waveguides, that means small a is equal to 2 centimeters and b is equal to 1 centimeters are given. Operated frequency is equal to 9 gigahertz, 9 into 10 power 9 hertz. So it is operated in dominant mode TE10. First we have to find the FC, that means cutoff frequency. So cutoff frequency F suffix C is equal to C by lambda C. C by lambda C. So here C is the velocity of the light. That means 3 into 10 power 8 meter per second. C is equal to velocity of light, velocity of electromagnetic wave in free space, that is equal to 3 into 10 power 8 meter per second. So, or 3 into 10 power 10 centimeter per second. Okay. Here lambda C is the cutoff wavelength. So, lambda C is equal to 2AB by square root of m square b square plus n square a square. This is the formula for cutoff wavelength. So it is operated in dominant mode. Dominant mode of the rectangular waveguide is TE10. So in this formula we have to substitute m is equal to 1 and n is equal to 0. put m is equal to 1 and n is equal to 0. So obviously we'll get lambda c is equal to 2a. Lambda c is equal to 2 into a. So here a is equal to 2 centimeters in given data. Therefore, lambda c is equal to 2 into a, that is equal to 2 centimeters. 2 into 2 is equal to 4. Cutoff wavelength is equal to 4 centimeters. Here cutoff wavelength is calculated, that is equal to 4 centimeters. Now FC, how to calculate FC? FC means cutoff frequency. FC is equal to C by lambda C. C is equal to 3 into 10 power 10 centimeter per second. Here cutoff wavelength is also expressed in centimeters. That's why here 3 into 10 power 10 value is taken. Divided by lambda C is equal to 4 centimeters. Okay. So here 3 by 4 is equal to 0.75. 0.75. Okay. Into 10 power 10. Into 10 power 10. So that is equal to 7.5 gigahertz. 7.5 gigahertz. This is about our cutoff frequency of a rectangular waveguide. So first cutoff frequency is calculated. Next, lambda g. Lambda g is also called guide wavelength. Lambda g means guide wavelength. So lambda z formula, lambda z is equal to lambda naught by square root of 1 minus lambda naught by lambda c whole square. Okay. So to find the guide wavelength, so we have to calculate lambda naught. Already lambda c is calculated. Lambda c is calculated. Based on this formula, lambda c is equal to 4 centimeters. Okay, already calculated. So we have to calculate lambda naught. So how to calculate lambda naught? Lambda naught is equal to C by F. C by F, where F is the operating frequency. In the given data, in the given problem, it is operated at 9 gigahertz. So how to calculate lambda naught? 3 into C is equal to 3 into 10 power 10 centimeters per second divided by F is equal to 9 gigahertz. 9 into 10 power 9. 9 gigahertz. So that is equal to 1 by 3 into 10. Okay. 10 power 10 into 10 power minus 9 is equal to 10. So 3 by 9 is equal to 1 by 3. So 1 by 3 into 10, that is equal to 10 by 3, you'll get 3.3 centimeters. 3.3 centimeters. Okay. So here lambda naught is calculated. So it is easy to calculate lambda z. Why? Because already lambda z is calculated. 4 centimeters. So therefore lambda z is equal to lambda naught. Lambda naught is equal to 3.3 centimeters. 3.3 centimeters divided by square root of 1 minus lambda naught 3.3 divided by lambda c 4 centimeters, already calculated here because it is operated in dominant mode. So lambda c is equal to 2a. 2a is equal to 2 into 2 centimeters, 4 centimeters. So here lambda c is equal to 4 centimeters. Substitute these values, we'll get lambda c value, guided wavelength. Roughly we'll get 5.84 centimeters. 5.84 centimeters. Next, cutoff frequency calculated and guide wavelength calculated. Phase shift. Phase shift means beta. Phase shift is equal to beta. So beta is equal to 2 pi by lambda c. There is a one formula, 2 pi by lambda c. So it is easy to calculate phase shift also. 2 pi, 2 into 3.14. 3.14. So 3.14 pi value. Lambda is equal to 5.84. So based on these values, we'll calculate beta, that nothing but phase shift. Okay. After that, we have to calculate phase velocity. Phase velocity. So how to calculate phase velocity? Here beta is equal to, we'll get 1.07. 1.07. So how to calculate phase velocity? So phase velocity is equal to omega by beta. Omega by beta. Omega by beta. Otherwise, by using this formula, c by square root of 1 minus lambda naught by lambda c. By using this formula, we will calculate phase velocity also. We know that c is equal to 3 into 10 power 10 centimeters per second. Lambda not calculated. Lambda c also calculated 4 centimeters. Substitute these values, you will get the phase velocity. And otherwise, omega. Omega by beta is equal to, omega is equal to 2 pi f. 2 pi f. Omega is equal to 2 pi f by beta. That is also called phase velocity. So here f is given. F is nothing but operating frequency. So operated frequency is equal to 9 gigahertz. Operated frequency is equal to 9 gigahertz. So 2 pi into 9 gigahertz. 9 into 10 power 9. 10 power 9 divided by beta. Beta is equal to 1.07. So you'll get some phase velocity. Okay, phase velocity. And last one, characteristic impedance. Characteristic impedance. So how to calculate characteristic impedance? Z is equal to otherwise Z suffix te. ZTE is equal to eta by square root of 1 minus lambda naught by lambda c whole square. Lambda naught by lambda c whole square. This is the characteristic impedance of a rectangular waveguide in TE mode. So what is eta? Eta is equal to free space impedance, that is equal to 120 pi ohms. Otherwise it is also or 120 pi ohms or 377 ohms. 377. So substitute these values in this equation, we will get the characteristic impedance. Okay, eta is equal to 377 ohms. Here lambda naught calculated. Lambda naught is equal to 3.3 centimeters. So lambda c also calculated. Lambda c is equal to 2a, that is equal to 4 centimeters. Substitute these values in this equation, you'll get characteristic impedance. Okay. So next problem, I will explain one more problem. So next problem, so an air-filled waveguide with dimensions 5 by 2, that means 5 centimeters is broader dimension and b small b is equal to 2 centimeters. Transports TE01 mode, find the cutoff wavelength. So it's very easy question. It's very easy question. Here cutoff wavelength is equal to lambda c. This is the formula for lambda c in rectangular waveguide. Lambda c is equal to 2ab by 2ab by square root of m square b square plus n square a square. So in this problem, waveguide is operated in TE01 mode. That means put m is equal to 0 and n is equal to 1. M is equal to 0 and n is equal to 1. So lambda c is equal to 2ab by square root of m square b square. Here m is equal to 0, so 0 into anything is equal to 0, therefore m square b square is equal to 0 plus n square a square. So here n is equal to 1, so finally we'll get here a square, that is equal to 2ab by small a. So here small a cancel, we will get 2b value. In the given problem, waveguide dimensions are 5 centimeter by 2 centimeters. Here small b is equal to 2 centimeters. So obviously it is easy to calculate lambda c. So lambda c is equal to 2b. So 2 into 2 centimeters, that is equal to 4 centimeters. That is equal to 4 centimeters. It is operated in TE01 mode. Okay. So this is very important formula. Lambda c is equal to 2ab by square root of m square b square plus n square a square. Here m is equal to 0 and n is equal to 1 values are substituted. So this term is becomes 0, and here n is equal to 1. 1 into a square is equal to a square. So square root of a square is equal to a. So 2ab by a cancel, will get 2b. So 2 into, according to the given problem, small b is equal to 2 centimeters. Small b is equal to 2 centimeters. So 2 into 2 is equal to 4 centimeters. Okay. I will explain one more problem. Problem number 3. Okay. Here, just observe the problem. When the dominant mode is propagated in an air-filled standard rectangular waveguide. That means that rectangular waveguide is operated in dominant mode. The guide wavelength at a frequency of 9 GHz is equal to 4 centimeters. Here the frequency 9 GHz is given. Guide wavelength, that means lambda g is equal to 4 centimeters. Calculate the width of the guide. That means width of the rectangular waveguide. So we have to calculate A and B, dimensions of the rectangular waveguide. So just observe the problem. So here rectangular waveguide is operated in TE10, frequency is equal to 9 GHz and lambda g is equal to 4 centimeters. So rectangular waveguide is operated in dominant mode, that means TE10. Okay. So frequency is equal to 9 GHz. Guided wavelength is equal to 4 centimeters. So given data, frequency is equal to 9 GHz. That means 9 into 10 power 10 gigahertz. Okay. And lambda lambda z is equal to 4 centimeters. Lambda z is equal to 4 centimeters. This is given data. Lambda z is equal to 4 cm. Calculate the width of the guide. So we have to calculate the dimensions of rectangular waveguide. That means small a value, border dimension, narrow dimension, small b value. Okay. So first we know that the relation between lambda g, lambda naught and lambda c. So that is equal to 1 by lambda naught square is equal to 1 by lambda g square plus 1 by lambda c square. This is the relation between lambda g, lambda naught and lambda c. So where lambda naught is wavelength, lambda z is guided wavelength, lambda c is cutoff wavelength. Okay, so lambda naught, how to calculate lambda naught? Lambda naught is equal to c by f, c by f. So here f is equal to 9 into 10 power 9, that means 9 gigahertz. So c is equal to 3 into 10 power 10 centimeters per second. So c is equal to 3 into 10 power 10 and f is equal to 9 into 10 power 9. 10 power 9. So that is equal to 1 by 3. 3 by 9 is equal to 1 by 3. 10 power 10 by 10 power 9. That is equal to 10. So 10 by 3 is equal to 3.3. Approximately equal to 3.3 centimeters. That is equal to lambda naught. 3.3 centimeters. Okay. So next, lambda z. Lambda z is equal to 4 centimeters according to given data. Lambda z is equal to 4 centimeters. So substitute this lambda naught and lambda z values in this equation. So we have to substitute lambda naught, lambda z values in this equation. So 1 by lambda naught square, that means 1 by 3.3 whole square, 1 by 3.3 whole square is equal to 1 by lambda g square. 1 by lambda g is equal to 4 centimeters in the given data, 4 square plus 1 by lambda c square. So we have to calculate the lambda c value. So how to calculate lambda c value? 1 by lambda c square is equal to 1 by 3.3 whole square, that means 1 by lambda c whole square is equal to 1 by lambda naught square minus 1 by lambda g whole square. So 1 by lambda naught whole square is equal to 1 by 3.3 whole square, that is equal to 1 by 10.89. 1 by 10.89. 3.3 whole square, 33 whole square is equal to 1089. That means 10.89 here. 3.3 and 10.89. Okay. Minus lambda z whole square, 1 by 4 whole square. So 1 by 4 whole square is equal to 16. So substituting these values, we'll get 0.0285. We'll get 0.0285. 0.0285. Okay. So how to calculate lambda c? So 1 by lambda c square is equal to 0.0285. So lambda c square is equal to 1 by 0.0285, that is equal to 35.0h, 35.0h, 35.0h. So I want lambda c. Lambda c is equal to square root of 35.08. Square root of 35.08. So we'll get 5.92. 5.92 centimeters. So remember students, in the given data, rectangular waveguide is operated in dominant mode. Dominant mode. So dominant mode of a rectangular waveguide is TE10. TE10. So in TE10, cutoff wavelength lambda c is equal to 2a. 2a. Just observe this formula: 2ab by square root of m square b square plus n square a square. So here put m is equal to 1 and n is equal to 0, will get 2a value in dominant mode. Cutoff wavelength is equal to 2a, m is equal to 1 and n is equal to 0. Substitute these values, will get 2a. So lambda c is equal to 2a. That means 2a is equal to 5.92 centimeters. So here the value is 5.92 centimeters. So 5.92 centimeters. Okay. So a is equal to 5.92 divided by 2. 5.92 divided by 2, that is equal to 2.96 2.96 centimeters. 2.96 centimeters. So in general, standard specifications of a rectangular waveguide to get maximum bandwidth, so B is equal to A by 2, especially in dominant mode. B is equal to A by 2. Dimensions are designed in this manner. So small b is equal to 2.96 divided by 2. So that is equal to 1.48 centimeters. These are the rectangular waveguide dimensions. Rectangular waveguide dimensions. These are all Jntuk problems. So simply concentrate on this concept. It is easy to present in your exam also. Okay. So very easy and no problem. Okay. So next problem. I will explain one more problem. An air-filled rectangular waveguide of inside dimensions 3 by 2 centimeters. That means small a is equal to 3 centimeters, small b is equal to 2 centimeters. Operated in the dominant mode, TE10. How to find cutoff frequency, phase velocity at a frequency of 3 GHz, guided wavelength at same frequency, same model. So these are the repeated problems in Jntuk. So just observe the given data. So here small a is equal to 3 centimeters, small a is equal to 3 centimeters and small b is equal to 2 centimeters, 2 centimeters, and it is operated in dominant mode TE10, TE10, operated in dominant. So we have to find the cutoff frequency, phase velocity, guided wavelength. Cutoff frequency Fc, phase velocity V suffix p, guided wavelength lambda z. Okay, in the given problem, operated frequency is 3 GHz. Operated frequency is 3 GHz. That is also very important. F is equal to 3 GHz, 3 into 10 power 9. So it is easy. How to calculate FC? FC is equal to cutoff frequency is equal to C by lambda C. I said earlier, lambda C is equal to 2ab by square root of m square b square plus n square a square. In dominant mode, put m is equal to 1 and n is equal to 0. Lambda C is equal to 2a. So based on dimensions, it is easy to calculate lambda C value. And we know that C is equal to 3 into 10 power 10 centimeters per second. So obviously you will get FC, cutoff frequency. Once cutoff frequency is obtained, it is easy to find phase velocity also. V suffix P is equal to C. C is equal to 3 into 10 power 8 meter per second or 3 into 10 power 10 centimeter per second by square root of 1 minus lambda naught by lambda c whole square. Already lambda c is calculated. Lambda c is equal to 2a, 2 into 3 centimeters. How to calculate lambda naught? Lambda naught is equal to c by f. C by f. Here c is equal to 3 into 10 power 10 centimeter per second. And f is equal to 3 gigahertz. F is equal to 3 gigahertz. That is the given data. So it is easy to calculate lambda naught. Substitute this lambda naught and lambda c in this equation. We will get phase velocity. After that, lambda z. How to calculate lambda z? Lambda z is nothing but guided wavelength, that is equal to lambda naught by square root of 1 minus lambda naught by lambda c whole square. Lambda c whole square. Already lambda naught is calculated. C by f formula. Based on this formula, lambda naught calculated. So lambda c also calculated based on this formula. What is the formula for lambda c? Lambda c is equal to 2ab by square root of m square b square plus n square a square. So obviously it is easy to calculate lambda c. Put m is equal to 1 and n is equal to 0 because it is operated in dominant. So in such a way, easy to calculate lambda z, phase velocity, lambda naught, and cutoff frequency. All these parameters of a rectangular waveguide. These are purely Jntuk related, Jntuk previous paper question. So it's not a gate related questions. So purely formula based questions. Please try to concentrate on these questions. Okay, it is easy to solve. Okay, with the help of little bit of concept, simple concepts. Lambda c value, fc value, lambda z value, and impedance formulas. Based on these formulas, it is easy to calculate. Thank you.